Hey students, so we're working on chapter 9F today on gradient. We've done a little bit of gradient last term, so you might sort of remember some of the tricks that we did there and shortcuts. We're basically focusing, this one here is looking at how to calculate gradient, realizing what it means when the gradient is a positive number or a negative number or a zero number, things like that. And we need to be able to find them from a given graph or even just look at it from a rule. In fact, I think looking at it from a rule might be next lesson. All right, let's get into it. Gradient is how steep, well, let me change color here to red so it's a bit easier to see it. Gradient is how steep the graph line is. The gradient is calculated with this formula. So I've got the gradient, that's the letter M, and it's the same answer as if you take the rise. How many spaces does the line climb up? So how many spaces does this line climb up? And you divide that answer by the run. And the run is like as you move across this many spaces. So we're climbing up a few spaces, and how much divided by how far across you run across. So if we look at this scenario here, oh yes, I got this little picture. That's going to be helpful. So this is Super Mario. When I was a kid, I remember playing this game, and I noticed that for this type of game that he plays, the two-dimensional ones, the platform ones, he always ran from this corner of the screen to this corner, and then the game would start to, you get to the next bit of the level. So that's been really handy for me as a little visual to eyeball. Just looking at some of the graphs. To read the graph from left to right, and you look at the graph line, and you just look at it as like, if Mario, the character, was climbing that, would they be going up? Would they be going down? Will they be staying the same? That's going to be telling me some indication about the gradient. So here, the gradient here, he is climbing up to follow this line. So this gradient in this picture is a positive number, meaning that he climbs. He's climbing up, and it's quite steep, so we're expecting a relatively big number. So we might be expecting like a 3 or a 4 or a 5 as the gradient number, just from my prior experience. So we're going to do the calculation now. I'm expecting it to be a positive number, and I'm expecting it to be around 3 or maybe 5. So we will have, I'll copy my rule here. So I got M equals rise over run. Now I'm going to swap in the, actually I should have used green because that's what I've got here, my title. Sorry about that. Keep it consistent. I'm going to grab some numbers from this graph. So I got these two spots. I don't know if you can see that. There's a coordinate right here, and they're telling me it's located at 1 and 3. That's the X value and the Y value, and they're giving me another data point down here, and they're saying it's occurring at X is a 0 and Y is at a -1. So let's have a look. How much, and we're looking for how much they've risen. Risen is going to be a measurement of height. So how much has it risen? So I can count the spaces. It's gone up 1, 2, 3, 4 spaces. So it's risen up by 4 spaces. And across how much horizontal distance has that happened? So that's happened over just one space across to get to the second. If I started from here and I went to here, that's one space towards the right. So that's going to be a 1 down here. And so my gradient is actually a 4. So I was pretty close to my estimation where it was a positive number, and I guessed it between around a 3, maybe a 5. So I was pretty close. It's literally as simple as that, and it does get easier as you do a few of them in a row. All right, so if the graph line falls, so here's a little Mario guy, then the gradient will be a negative number. So we'll get that by doing a calculation in a moment. But here, remember, to finish the level in the two-dimensional flats game of Super Mario, you would have to move left to right. And if he was to follow the line, in this time, he would actually be falling. He's going down. So if that's happening, then we are going to expect a negative number. And there's a little hint here. Look for good spots where the graph line lines up with the grid. So here's my graph line. if I'm looking at it, I won't pick spots like here because I can't really accurately get the numbers of exactly its x position. I'm not really sure. I've got a very good number for its height, but its x position, horizontal position, is not very clear. Here is actually a good spot because I can see it crosses over both of these two bits here on the grid quite nicely. This spot here, again, not very good because it's not lining up with the grid, so it's a little bit more guesswork to try to figure out what the numbers are. So here, I could choose these 2 points here that they've labeled for me. I don't have to use them. I could actually use that spot and this spot because they line up with the grid just nicely. So I'm actually going to choose to do this way. It's going to be a little bit less work. So here again, we got the gradient, the letter m, is equal to the rise, how much you change vertically, whether you climb up or you fall down, over the run, which is how many spaces you've moved from left to right. Actually, now in hindsight, I want to look, that's what I did earlier here with pink, where it's just one space to the right. I might do it this way just so that this maths here works a little bit more in a more interesting scenario, okay? In reality, I would have picked here and it's less work, but I'm going to pick here because I want to show something different for the run than what I've done just previous. So I'm going to use this one as well. All right. How much has Mario risen? Well, he hasn't. He's actually fallen down. So he's actually come down 1, 2, 3, 4 spaces down. So he's fallen. Now, how do I show that he's fallen, but he's going down, not going upwards? Well, to show down, I'm going to show a negative sign. So it's going to go with a -4 as my rise. And how far did he run in that duration from this spot to this spot? Well, that is one space and another space horizontally. So that's going to be a 2 on the bottom. Now we do a little bit more maths working. So -4 divided by 2, that's going to give us an answer of -2 is our gradient. Okay, so hopefully that makes it clear why the gradient ends up being a negative number when the graph, when it's falling. All right, looking at some other scenarios because the chapter is, insisting we look at these scenarios too. If the graph line stays flat, so here's Mario and he's following the line, is this graph line steep or is it kind of flat? Well, it's flat, so there's no steepness to it. So no steepness would mean that the gradient is 0. So that one should be clear. This one here, if the graph line is so steep, so he's coming across and bang, he's basically hit a brick wall, and the graph is so steep he basically has to take an elevator, well, there is no, we're not going to put an infinite gradient. In fact, we just put it's just undefined. There is no number. So just keep that in mind, that if the graph line is perfectly straight up and down, like here, that's undefined. I don't think that's worth knowing. I've never found that a useful thing, but just making sure, covering the things in the book. All right, so here's a quick question. You're going to hit pause in a few seconds after I read the question for you, and you can have a go. And then once you have finished answering it, I'm going to hit play so you can hear the rest of my sentence with the answers. So it says, decide if the lines marked A, B, C, and D on this graph have a positive, negative, 0, or an undefined gradient number. So let's quickly look at it. So A, is that a positive, negative, undefined, or a 0 gradient? B, etc., etc. So I'm going to hit pause. 1, 2, 3, hit pause and try the question. And we're back. So let's look at the answers. So this gradient here, Mario starts on the left and he goes towards the right. So to follow this line, he would have to fall. So that'll be a negative gradient. So question A would be a negative gradient. The line here for B, it's perfectly straight up and down. It's like an infinite gradient, so that's undefined. So that's the answer for B. For question C, so again, if he wants to climb this one, he's going to have to go up. So that will be a positive gradient, so it'll be a positive number. Last one here, D. If he was to follow that, he's not falling, he's not rising, so he is staying the same. There is no steepness, so the gradient here is 0. All right, moving on. So we're going to do some more calculating of gradients. I'll do this one. So the gradient is rise over run, and I can put the numbers in there. So looking at some spots where the grid lines up beautifully with the graph. So here I'm going to count how many boxes does it climb. It climbs up 3 boxes. And how many spaces across does it do that? Just 1 space across. So the gradient here is 3. And we just tuck that out the way. There it is. The one down here is a little bit different. So you might notice that I've picked this one from question 3 of the book. All of them are positive, so they're all climbing ones. I went down to question 4 to find a falling one, so I'm expecting a negative result. So if my calculation works out correctly, I should get a negative number. Rise over run. I put my numbers in, so look at where it lines up beautifully with the grid. So if I zoom in, I think that's a good spot here because I know that's happening at location 0 and 0. And then I keep looking around here. That's not a good spot because it doesn't line up. This is not a good spot, doesn't line up. This is not a good spot, doesn't line up. And in fact, it doesn't line up beautifully until it gets to here. So I have to use those 2 locations. So if he was to follow this line, he's falling. So I'm expecting a negative number here. How many spaces did he fall? 1, 2, 3 spaces. He has fallen down. And how many spaces across did he run? So he's gone 1, 2, 3, 4, 5 spaces across. So -3 divided by 5 is the gradient. At this point, I make a decision. Do I change this into a decimal number or do I leave it like a fraction? I'm inclined to leave it as a fraction because I don't know off the top of my head if it divides cleanly. Like, will I get forever decimal places? Probably not, but I do think it's a bit cleaner to leave it as a fraction, so I will leave it like that. In fact, it is allowable to have fractions for the letter M. It is allowed as a response. That's perfectly fine. It can be a decimal, it can be a fraction, and it can be an integer, a whole number, positive or negative. Here's 2 that I would like you to try. So on the count of 3, you're going to hit pause. And then when you unpause it, I'll put up the answer for you. So 1, 2, 3, hit pause. And coming back, we have answers. So this one here, the gradient would be, okay, rise over run. This one here, it's rising by 1 space and it's running across 2 boxes to get there. So that will be the answer for this one here, rise over run. And I'm looking at it, it is rising 1, 2, 3, 4 boxes. So it's rising up by 4 and it's running across just 1 space. So the answer is 4. Okay, now we're going to try these questions here on the count of 3. You're going to hit pause. 1, 2, 3, hit pause. And coming back, we're going to go through the answers. I might change color a little bit. No, I'll stick with green. This one here, these are all falling graphs. I'm expecting the outcome to be a negative result. So rise over run. Is the little character dude, are they rising or are they falling? No, they're falling, so it's a negative number. How many spaces did they fall down? Where does it line up nicely with the grid? It lines up here and here. I could use those. I don't need this one because that's actually easier. So it's falling down by 1 box and it's running across just 1 space. So the answer is -1 divided by 1. That's a -1. Let's go to question E on the right. M equals rise over run. And looking at when it lines up with the grid, it lines up here and it lines up here. So I have to use those locations. So are they rising? No, they're falling. So it's a negative number on the top. It's going down 1, 2, 3 spaces. So down by 3. And the run to get from those 2 locations is just moving across horizontally 1 space. So -3 divided by 1 is still -3 is the answer. Let's have a look. Oh, yes. I know I was looking at the past exam and seeing what questions they had like this. What I did notice was that we probably should have a bit of a refresher on how to use this. So we had questions last term where it says find the rule from a table that's given to you. So bring this one out from the past. This is the general rule. general rule for a straight line graph, we've got the y-intercept, and we have our gradient. Okay, so we just need to find those two numbers, and we've built the rule that matches this table of data. So where do I find my y-intercept? The y-intercept, so I'm just going to draw it visually. So if I have a graph, let's say it's in purple, let's say the graph is like that. The y-intercept is where you run across the y-axis. So what number is 0 at this location? It'll be the horizontal location is a 0. So if we look for when the x-axis is a 0, so here's my x-axis, and I look for when it's a 0, there it is. And the table tells me that the y position is at -4. That right there, -4 is going to be my y-intercept. So I can just put that in. So y equals something x -4. It's actually going to be it's going to be changed to a takeaway 4, so it's the same idea. We need to find that gradient. To find the gradients, we just look at how much the y value is changing as we go across the table. So I'm going from -8 to -6. That's less bad guys. We're actually getting some good guys to kill them off. We would need 2 good guys to get to -6. We would need another 2 good guys to get to -4, another 2 good guys to get to -2, and another 2 good guys until we kill all the bad guys. So we are increasing every single time by 2. That's actually going to be, and it's a positive 2, so that's like the little plus sign 2. And that finishes out our equation or the rule for this table. I just will remind you that if it's at the very start of a line, you don't like start of a sort of a part of the work. The plus sign is not required. It's just there. It's already assumed. So if I write any number, so let's say I put 7, then you automatically assume that that is a positive 7. Only if I want to tell you that it's not, do I have to put a sign in front of it. So if I put that 2 in there, you will automatically assume it's a positive 2. There we go. That's a bit of a refresher. Some word problems. Abdullah climbs a rocky slope that rises 12 meters for each 6 meters across. His friend Jonathan climbs a nearby grassy slope that rises 25 meters for each 12 meters across. Which slope is steeper? So this is a word problem for gradients. Some clues that we can see here that it means that we can use these tools we've done here about rise and run. We can see the word slope, both of them, and then the numbers follow. So we see the word rise. Actually, I might use orange. It rises. Both of them say rises, so going upwards and upwards. And they also mention, well, the color, but I'll use pink, 6 meters across, 12 meters across. So that sort of implies we're going that way. So this is going to be clues as to, we're going to use the rise over run formula. And we have to respond from these 2 people in the story, which one had the steeper slope. A steeper slope would be a steeper gradient, a higher number, a more positive number. So that's going to be our clues. Let's quickly do our calculations for maybe Abdullah. I'm just labeling my work, Abdullah, and I'm going to put the little ... My M is rise over run. Put the numbers in. It rose up by 12 meters, and we divide that by 6 meters across. And processing that one out, 12 divided by 6 is just 2. So there's the gradient. It's not meters. We don't have a unit. Gradients don't have units. It's just a number. It's kind of like ratios where they don't have units anymore because they cancel out. So you see this little m here, it cancels out that little m down there. So we don't have units anymore. So we now have an answer for Abdullah. Now we look at the other character, Jonathan. So I might use green for Jonathan. For Jonathan, we got the gradient equals rise over run. We put our numbers in. So we got 25 meters from the question. Divide that answer by the 12 meters across, which is the run. And we look at that, and I can't divide that in my head. So what I might try, I don't have my calculator next to me, so I'm going to try some things. These will cancel because there's just one m on top and bottom. I can divide them both with, can I divide them with 2? No. Can I divide them with 3? No. What I might do, it's going to be 2 point something. It's going to be 2 point something because double of 12 is 24. So, and 25 is a little bit bigger than that. So it might be like 2.1. So I think Jonathan will be the one that has the steeper slope. Steeper slope. But if I had this would have to be a calculated question, and I don't have the calculator with me right now, unfortunately. Sorry about that. Looking at these ones, find the gradient. It's an abstract question, which is why I picked it from the textbook, because I need to make sure that you can do different types of questions for the same idea. Here we had a stimulus, which was a table. Here we had a stimulus, which was a literal graph. Now we're going to try to do the work without any visual at all. It's just the numbers alone. So I need to remember a key fact. So find the gradient of the line joining these pairs of points. So that's a point, and that's another point. And the numbers that we're seeing inside these round brackets are coordinates. So we have the first number is always the x value. In fact, for all of these down here. And the second value is going to be my y value. Now, if you ever forget which letter, which one is which in the coordinates, so here, just remember that the numbers will appear alphabetical sequence. So x comes first in the alphabet, then the letter y, and then the letter z, and so on. So the first number would be an x number, the second number will be a y number, and if there was another, there would be a z number. So looking at this, we can see, we'll do our rise over run. And I might go, yeah, I'll go down. How much have they risen? So how much, they started off with a y position of 2, and they finished at a y position of 7. That's actually gone up by a few spaces. That's actually gone up by 5. One way we could, if you're not sure if these numbers are really, really big, let's say 512, and this one here is 498, if the numbers are really big, you could do it this way, where I take the last one, where you end up at, so 7 take away 2, that's another way I could write this one out, and I look at the run, which is, okay, so we started off at 0, wrong color, I'm supposed to go with red. We start off at 0 and we finished at 2, so we've definitely gone up by 2. Again, we could go where you finished at and subtract from where you started. It's just letting you know this is one way you could write it out, and sometimes this is going to be handy. I find it's going to be handy when the numbers are strange, like really big numbers. 7 take 2 is 5, 5 over 2. 5 over 2, so we could write this, we could leave it as 5 over 2, or I could write this as, I might go this way, I could divide that cleanly in decimals, so it'll be 2.5. Which one should I leave my answer in? Well, the question didn't really ask me to present as fraction or to present as decimal number. I think both are fine here. That's the end of the video. I would encourage you to try some questions on your own, particularly with finding these gradients. But I think we're getting on to, we've done this quite a lot now, across term 3 and now into term 4. So I think you'll be pretty fast at these. Good luck.